All right, good morning, good day, good afternoon, ladies and gentlemen, and welcome to the Juniper Systems Geode Real-Time Sub-Meter GPS Receiver Product Overview. I want to thank you all for signing up to attend, and since this is our first presentation, we'll be recording this so we can make it available for you to download later. Also, all the slides will be made available to everyone who has registered, and we'll have record of that on our website. Get the slides going here. And there we go. All right, my name is John Florio. I'm the Senior Product Manager here at Juniper Systems. And I have working with me today, Kirk Earl. Hi, everyone. He's in charge of our Marketing Communications Department. Just some housekeeping items for this presentation. If you haven't used GoToMeeting or GoToWebinar before, you'll see on the right where you logged in there is a chat bar where you can enter in questions at any time during this presentation. If questions come up during a slide, we may address them immediately, or we will have a question and answer period at the end of the presentation. If we run out of time answering questions, we will compile all those questions and send answers to everyone out as an email after the presentation. So, starting off, who are we? We're Juniper Systems. You might recognize us from our website and some of our kind of fun videos that people have commented about online, where we like to take the products that we build and smash them against things. But what we do is we build rugged mobile computing systems and solutions for people who do work in the field. This picture here is a picture of our building located here in Logan, Utah. It's a 45,000 square foot facility. This is where we engineer, design, manufacture, assemble, produce, service, and repair, and do all the aspects that deal with the products that we send out to the market. All of our products are made right here in the USA. We serve a diverse group of different markets. What's in common with all those markets is their need for reliability. We strive to maintain the lowest warranty failure rate in the industry, and we tend to focus on quality. We're an ISO 9001 certified facility, and we practice that throughout our business. We have a world market presence. We've been doing this for some time now, so we're pretty well established worldwide. We have customers in over 80 countries. I mentioned, of course, we have our office here in Logan, Utah, in the United States, but we also have an office in Europe, in Birmingham, in the UK. They cover all of our customers in Europe, the Middle East, and Africa. We also have a couple field offices, one in Kansas City, Missouri, and another one in Wales, Austria, that serve our Harvest Master brand agriculture customers. We tend to work with resellers and with developer partners worldwide, delivering products to suit their customers' local needs and focus on integrated solutions. We've been around for over 20 years. This picture here shows a picture of our founder, Ron Campbell. We've been building rugged mobile computers since they were available, really, starting with the earliest versions of DOS. We've produced products that have run DOS, Windows CE, Windows Mobile, and just not too long ago we released our Mesa 2, which is a full Windows PC tablet device, which we'll show a little bit later through this presentation. But first things first, onto the Geode product. So, what is the Geode? It's a solution to a problem. That's what we do here. We try to find solutions to solve people's problems, and we start out with what problems they're having today. So if you look at the pictures on the left, this is just representative of different types of devices or solutions that people might be using when they're trying to capture information, and information that includes the where, the positioning information of where something is. They may get a fully integrated system. It might be rugged and accurate, but they have problems because they can't move the accuracy solution to another device when it wears out. They might get something that's durable and reliable and versatile, but it might not have the best positioning solution. They might be able to get an inexpensive add-on positioning solution that they could connect to their device, but it may not be as accurate as they need, or they may have some really cool new technology, maybe a brand new smartphone or a brand new application that they found that works on their smartphone, but they're missing the accuracy and the durability, reliability in the field. So when we put all these things together, we came up with a convergence of needs that our customers might have. They want something that's accurate, reliable, rugged, portable, meaning they can move it around from device to device, and of course compatible with what they're using today. The inspiration for that, we've internally kind of called it the GPS hockey puck. The idea was to make something that was as simple, as rugged, and as reliable as a hockey puck. Internally, the project was named Project Gretzky. I wanted to pick someone who I thought was one of the best hockey players ever, although there's some who would probably challenge that, if we mention Bobby Orr and a few others. So the product that we created from this project is called the Geode. The concept, like we said, is a high-accuracy GNSS receiver that interfaces with a wide range of devices, both vertical rugged devices and consumer devices. It has a modular design and a modular interface, meaning it's open. The firmware is upgradable, and the bottom line design concept was it had to be affordable accuracy. We know that our users are going to use it in lots of different ways and lots of different environments. They want to use it with their handheld device. They might want to mount it on a pole or put it on a backpack. They might attach it to an ATV or put it on a vehicle. And they might be doing lots of different kinds of work, working around water or working in inclement weather. They might have it mounted on something like a snowcat or even a research harvester. Or they may be working around utility equipment or even doing hydrographic surveys on a beach. So what we did is we came up with this product, and it comes together as a series of pieces and parts here. We have a rugged outer housing that seals the product against the elements. So it's an IP68 rugged device, like our other Juniper Systems products. And it's a long life integrated battery. We made this choice because we wanted the product to last for a long time and be able to run for a long time. We use a precision GPS or GNSS receiver engine from a quality manufacturer. We're actually using a hemisphere receiver board. And we created an interface board that everything attaches to. And then we also assembled a high-quality antenna with an integrated ground plane. The antenna comes from another quality manufacturer out there, Talisman. Makes some really nice compact antenna assemblies. So we designed that all here. It's a Juniper branded product. We also manufacture it here, and we will service and repair it here should that need to be done. The final product looks something like this. It's a simple square-shaped 4-inch to a side product, and it's about 1.5 inches deep. One button on the front, a few LEDs, and ports for you to connect to. We have a complete spec sheet posted on our website. I'm not going to go through all those here. I'll just go into some quick specifications. The receiver itself is a single frequency receiver with carrier tracking. It supports GPS and GLONASS and SPAS. The normal update rate is 1 hertz, but it can be upgraded for 2 to 10 hertz output rates. Its accuracy is better than 30 centimeters horizontal RMS, or if you do a 2D RMS calculation, or 95% of the time, it's better than 60 centimeters. And we'll show some data from what we've been able to capture out here in the field. And it also supports RTCM in corrections. The communications, the primary communications interface, is Bluetooth 4.0. That's a serial port profile. And we use a Class 1 long-range Bluetooth module because that allows people to mount this on things like vehicles or distant from their computing device. We also have some ports on the device. We have a USB charging and communications port, and an external antenna option port, and then some models can be ordered with a 9-pin serial port. The power uses our same batteries we use in our other products. We call it overtime technology. It's a long-life lithium-ion battery, and in testing it runs between 10.5 and 11.5 hours. And that's normal field use. Receiver protocols are standard NMEA 083. There's also a raw binary protocol that can be output and integrated into developer software. And of course, the device supports RTCM. It's Juniper rugged, meaning it covers a wide temperature range, -20 to +60C, and the enclosure is rated IP68. That means it's rated for extreme dust environments, and it is submersible, although when we did some testing we discovered the product actually floats, so we don't worry too much about immersion. And like I said, the dimensions is about 4 inches to the side, a little more than 1.5 inches thick, and weighs about 3/4 of a pound. There's 4 models available. This gives people the ability to choose what features they need without buying features they won't be using. The 4 models start out with a Geode GPS-only model, and you can get that also with a 9-pin port. And then we have the Geode GPS and GLONASS, and a 9-pin port version of that is also available. For a quick overview of the hardware, it's a very simple user interface. 1 button to turn it on and turn it off. 4 indicator LEDs, and they're very bright. They're good for outdoor use. And then we have 2 ports, an external antenna port and a USB charging and communications port. The 4 LEDs on the front give you information about your GPS fix, your Bluetooth connection, the status of charging of the battery, and a power indicator and a low battery indicator. Each port, the USB port and the antenna port, are covered with this protective cover, but that is only to keep dust out. Both of the ports are fully sealed ports.
John, the audio cut out for about 5 seconds on the last slide. Do you mind just backing up one?
Sure.
Not sure why, but GoToMeeting gave us a technical difficulty message, and
All right.
it says that it's restored now.
All right. Which slide was that?
Just literally 10 seconds ago, so just need to back up.
Okay. So back over the hardware, in case you didn't hear it. We have indicator LEDs and a power button, and 2 external ports, the antenna and the USB port. 4 LEDs for GPS fix, Bluetooth, charging, and power and low battery indicator. A sealed USB micro port, and a sealed MCX antenna port. And then some models can be purchased with an optional 9-pin port, which comes out of the bottom of the device. Here's a picture that shows the different mounting options for the product. Oh, by the way, we also print the serial number and part number in a little visible window on the outside of the product, and that number is what will also pop up when you connect to the device. So if you're managing more than 1 device, you can see the name of the product and the serial number to match up with your hardware with easy identification. So the connections on the bottom, we start out with a 1/4x20 standard camera tripod insert. This fits lots of different low-cost consumer solutions that might be out there. So a lot of people to attach this product to almost any solution they can come up with. And then we also provide with the product a 1/4x20 to 5/8x11 GIS survey pole adapter. And that's a standard adapter that comes with the product and should fit on most of the poles that are being used today. We also have 2 inserts either side of the main 1/4x20 insert, and these are 2 6x32 inserts that are in the standard amps mount pattern. So they match up with most of the RAM mount accessories that are out there and most other vehicle mount accessories you might find. This is good for those customers who might need a fixed mount solution. So just to show some use cases, some examples, of course you could put this on a pole. Here's a picture of one of our associates here using it with the Mesa 2 and the tablet. Of course, you can attach it to a magnetic mount and put it on top of the vehicle. This happens to be my boss's truck, so I hope he doesn't mind that I use it. Here's another fun little idea. If you want to be able to encourage your users to map a specific point, but you want them to be small and lightweight and portable, you can buy a camera monopod at most big box stores, which would attach to the bottom of the Geode and give you a quick and easy pole to use as your mapping points or lines around a mapping project that you're working on. The nice thing about this solution is you could also use it as a backpack pole. We don't provide these ourselves because they're easily available at most big box stores for anywhere between $15 and $20. We're also developing an accessory that will be available shortly after the product launches, which we call a smartphone tray. It gives you a little mount that you can attach the Geode and whichever device you want to bring to the product, any smartphone device. Here we have an example of our CT4 rugged Android smartphone, and you can carry everything in one hand. The standard accessories that ship with the product, obviously we have the Geode, and then we have a universal USB charger. It's a 10-watt output charger, which, by the way, you could use to charge your phone if you need to. And then we provide with it charging adapters for the UK, EU, Australia, and New Zealand. With every product comes the 5/8 by 11 survey pole adapter, and we also include a USB charging data cable. Now, we also recommend that users use the USB cable that we provide with the product to ensure that the charging happens efficiently and as quickly as possible. The charging time on the battery is about 4 hours if it's fully depleted. You can use other USB cables that you may have, but they might not charge as quickly as this combination with our charger and our cable. Along with the hardware, we provide some software, and the software is called Geode Connect. The software's purpose is not to be yet another mapping product that you can find out there for all different types of operating systems and different types of jobs to be done, but to provide a quick and easy way for a user to get the Geode to interface with their device. The Geode Connect software provides the ability to establish the Bluetooth communications between your handheld or your PC and the Geode, and it gives you the ability to configure all the settings on the receiver. We've also made it simple by putting some quick modes or quick environmental settings to deal with the most common use environments. The default mode, we call it open sky. It just means the most common mapping environments. Then we have a mode that we call forest, which we recommend for semi-obstructed environments, such as heavy tree canopy or a lot of urban canyons. And then we have a fast mode. If someone's mapping in a vehicle, they might set this mode so that they don't have signal loss when they're passing under bridges, tunnels, things like that. The fourth mode that displays is custom. That just means that something else has been configured. The software provides basic diagnostics, position, elevation, speed, estimated error, and it's written for most of the major operating systems for Windows Embedded Handheld or Windows Mobile. So it supports all Juniper Systems devices. For Android, so it supports the Cedar Tree devices that we sell and any Android smartphone or tablet you may have out there. And also Windows 10, so it supports our Mesa 2 and other Windows PC products. The software will be available for download from our website, and it will also be available on the appropriate app stores for the particular operating system you're using. Now, if you'd like, I can just give you a real quick view of what the software looks like. I'm going to step out of the presentation here. I'm going to bring up the software. And this is what the home screen looks like. And if I click this big button right in front, ask what I want to do, and I'm going to connect. So I have a receiver just over in the other room here that's exposed to the sky, and you can see it's giving us a latitude, a longitude, a fix. We have a differential GPS fix, so we're getting a loss solution. It gives estimated error because it's inside a building. The main screens on the product include the home screen, the sky plot screen, which if I resize it, you'll see the display typically looks like that. And then we have a terminal screen, which shows the output from the receiver. And you can see the various NMEA strings coming in. To get to the settings, you click the little icon right here. It goes to the receiver settings, and this is where you can control all the settings on the receiver. Setting the quick mode, setting the update rate if it has multiple update rates configured. Select different NMEA messages you want to output. And control what type of corrections you're receiving or other receiver modes. We also have a reset feature. You always have to have that ability to reset the receiver if you run into some issues.
John, there's a question that's applicable right now.
Yes.
It was asked, what's the version output of NMEA?
The default version is version 4, but the receiver is configurable up and down and compatible with other versions. On the PC and on the Android versions of the software, there's also this beta feature in here, which is NTRIP configuration. This would allow a user to enter in the IP address, port, and login instructions for an NTRIP server if they have access to one, and provide decompressed RTCM data up to the receiver. On the PC side, it's mostly just demonstration at this point because we want to get feedback from our users. On the Android product, you can't configure mock locations to output the RTCM corrected data, just like the normal SBAS corrected data from the receiver to any of your applications. And that's about it. The software is very straightforward, very simple, easy to use. Preferences are basically how do you want it to display, English or metric units, and setting up connections to different devices. When you do connect, if you connect to a Geode, it will display the name of the product. Here's the serial number that will be on the bottom. It'll show a little icon. It also shows the COM port that has been configured for your Bluetooth communications. So if you establish communications and then quit out of the software, you can connect your application directly to the USB port that has been configured. All right, I'm going to jump back over to the presentation. Yes, sir. You had a question?
Yeah, a couple of people have mentioned that there's a little bit of lag, and they're asking if you just briefly go back over the correction option more slowly.
Oh, sorry about that. All right, the default corrections that are available for the Geode would be using any SBAS correction. So WAS, EGNOS, MSAS, that covers North America, Europe, Asia. GAN is also supported. But the receiver also supports RTCM in. And if your application can deliver RTCM to the receiver, then the receiver can use that as a correction source and deliver out corrected, accurate positions based on that RTCM output. All right. I apologize if my mouse has been jumping around here. I have a different mouse attached to my computer. I'll try to not move it so fast. Let me get the presentation back up here. All right. So we talked a little bit about what the product is. Now how does it actually perform?
There are a lot of questions about accuracy, so hopefully you'll answer all of them. If not, we'll try to get some of them in the
perfect
question.
Because we're inside, we can't do a demo right here, but what I can do is I can show you what we did a couple days ago. So this is our building right here in Logan, Utah. And around the building, we have a number of control points that we've mapped out with a survey-grade RTK receiver. And we've checked them multiple times, so we know exactly, well, we know as close as we can where these points are. We should never say exact measuring. But we did some mapping right out here in the front of the building. I'll zoom in. And we use these 4 control points as our reference points. Just to give you an idea of what the environment looks like, this is basically the entrance to our building complex. And this is one of our sales account managers here, standing at each of the 4 points. So it's a typical open sky, parking lot demo type of environment. It's easy for us to walk right outside and do this. The data we captured, we use, I'm just going to mention this, we used EasyTag CE from a company called Effigus. The reason we use that is that allows us to capture the data real time and then also post-process it later. I'll be showing the results from both. The other thing I should mention is if you'll notice how he's holding the receiver and his data collector using an Archer 2, that you have to think in terms of the antenna location and antenna masking. So we do have some blockage from the tree here and from, obviously, from the operator standing close to the antenna. But the results are still quite good. So we captured 80 points all over the site, basically doing multiple rounds of those 4 points. Half of them were captured as 1-second observations, and then the other half were captured as 60-second averaged positions. And then we generated a ASCII file output and a KML file so we could display it in Google Earth. So this is what it looked like. We went around these 4 points 20 times, lots of laps. And the resulting data, and this is the real-time data, SBAS corrected, that shows the positions that we captured on the 4 points. There's 20 captured positions at each one of these points. Now, if we had done this with a smartphone has a limited resolution. The little blue dot on your smartphone, when you zoom in, would look something like this. Depending upon the device, it's only good to 1 to 5 meters. This is kind of the reason why people are looking for a product like this. Because this product can connect to their device, yet deliver the accuracy they need. The product's intended to be a professional device, gives you high accuracy positions, better than consumer grade receivers. The image here, we now drew some 1 meter circles, a 1 meter radius circle around each of the reference points. And when I zoom in, you can see that all the points are well within inside those circles. Now, if I take all of that data and compile it onto a spreadsheet, it looks something like this. This is a scale in tenths of meters. And forgive me if I'm using English and metric units. We have people listening from Europe and South Africa and some other parts of the world, as well as here in North America. And here, of course, in the US, we use our funky English measuring system. So I have a circle that's a 1 foot radius of the 80 points that were captured. And I did some calculations using the standard calculation methodology that we use, which is the same as what the US Forest Service uses. The average was 0.281 meters, all those points from the reference point. That gives us a root mean standard error of 0.309 or 0.31 meters, or a national standard for spatial data accuracy calculation, which is basically a factor multiplied against that RMS value of 0.535 meters. So you'll notice out of these 80 points, 76 of them landed within a 1 foot radius. Now what about elevation? The elevation was also fairly high quality. The green bars indicate plus or minus 1 foot, and again the scale bars above and below are in 0.2 of a meter. And you'll notice that the majority of the data is within that 2 foot range. The average was just outside of 0.26 meters, giving us an NSSDA calculation of 0.77 meters altogether. Pretty good data. Now remember I said we also captured this data with EasyTag so that we could post-process it. So I'm going to show you the post-process results. Using EasyTag and EasyServe from Effigus, this is a partner we worked with for a long time, we're able to capture the data real time and then post-process it against a local base station using a core site. In this instance, we actually use a UNAVCO site, but if you look at the post-processing software, EasyServe, there are thousands of base stations you can use and almost every projection you could possibly want. And the ability to output in Google Earth files, Esri shape files, DXS, and of course a ASCII CSV file. So when we post-process the data, this is what we got. Almost all the points fell within about 1/10 of a meter. We have the same circle, 1 foot radius. The average was 0.069 meters. The NSSDA calculation came out to 0.130 meters. The base was 21 kilometers away, or about 13 miles away. It was a UNAVCO station. And just to demonstrate, just for scale, the orange box in the middle represents the physical size of the geode itself. Now, I'm not saying these are the results you will get by using a geode. I'm saying these are the results that the receiver is capable of producing when post-processed. Nonetheless, it's pretty darn good. And when we look at elevation, same type of thing. We have our plus minus 1 foot box, and we see now that almost all the data is well within a foot. We get an NSFPA calculation of 0.086 meters processing the data. So end result looks pretty darn good. Now, as far as what can you use the Geode with, because it outputs industry standard NMEA messages, and because we've written the interface software to work with multiple operating systems, you can use it with Windows Mobile or Windows Embedded handheld devices, with Windows 10 devices, and with Android devices. I was a little frustrated trying to make this slide because there's lots of partners we have out there that have software solutions, and they're all very good. I just wanted to give some representation of some of the options that are available to people and some of the applications we have been using in-house during the development of the product. On Windows Mobile, we've been, of course, using EasyTag and EasyServe and ArcPad and our own Juniper Aspect mapping product, as well as Data Plus from Elect Data Solutions. Windows 10, we were able to run EasyTag CE, and of course, you can run ArcPad also. And we ran the product with Esri Collector and Survey 123, which is still in beta, soon to be released. On Android, the product works quite well with TerraGo and with Avenza PDF Maps, as well as Collector and Survey 123 and other Esri products. And a number of these people are also our beta tester program, and they're going through the process of testing this product right now. There's many more apps out there that work with this product. Just recently, I was at the Geo Business Show in London, and I saw a really neat application from a company called Taxis out of Poland. I believe the product is called T-Map, and it's a really sophisticated, really nice Android-based mapping application. Worth looking at. So, current project status, where are we today? We're almost complete with the project. Right now, we're finishing up our beta testing. Of course, obviously, we've done some internal training here and started out by doing webinars like this. Once our beta test is complete, we'll do our design finalization and project review. Hopefully, we won't have any major issues come out of beta test, but thankfully, we've been doing a lot of internal testing, and our beta testers have been helping us out greatly. And then we'll do our pilot build, and if everything goes great, we'll ship the product, and we're looking at shipping hopefully by the end of July. So with that, that's pretty much the presentation. We're ready to go over to questions. And Kirk, do you have any questions that have rolled in?
Yeah, there are several. We may not be able to touch on all of them live here, but we'll definitely send those out via email and answer them after the webinar. First, which hemisphere GNSS receiver engine is in the product?
The engine we're using is the P206 receiver. And the antenna we use comes from a company called Talisman, and that's the Talisman 2710 antenna. And we work with Talisman to tune that antenna and put a custom ground plane with it, so we get best performance inside the case. Hemisphere has been a long partner with us with previous products such as the XF101 receiver, and they've been great to work with.
All right. There are several questions about price. Maybe you should just touch on the price range again.
Oh, sure, yeah. I'm not surprised that came up because you got a pretty accurate product here, so people are probably wondering, what does this cost? $5,000, $8,000, something like that? Well, the product actually starts out at just under $1,400. We're going to have 4 different models that we can ship with, and the price range retail is somewhere between $1,400 and $1,900, depending on how it's configured.
Compatibility with iOS?
Compatibility with iOS, that's a great question. To make a device compatible with iOS, you have to add some components, and you have to go through a made-for-iDevices certification process. So in our initial launch of the product, we're compatible with Windows Mobile, Windows PC, and Android. We have iOS on our roadmap, depending upon design, or depending upon demand we hear from the audience. If we see a lot of people who are asking for that, then that will probably be the next thing we build into the product. I believe there is a third-party product out there from a company called Amon Enterprises, which can interface with GPS devices. And if you get the model, one of the models that we have with a serial port, you can attach that device to the serial port and have an iOS interface.
All right. Good, thank you. What does the external antenna provide in terms of accuracy improvement?
Okay, the external antenna port is intended to provide the ability for users to remote the antenna if they do not want to have the entire device and housing exposed outside. Now, it's a fully rugged device. It's designed to work in a fully rugged outdoor environment. One of the reasons the antenna port is there is simply because we have to have a secondary port to make sure that everything's working, and for competitive reasons, we have to be able to provide users that port. Now, with that external antenna port, if you were to use a full-size geodetic antenna, you would probably see some improvement in the post-processing of data. You would probably also see some improvement in any real-time data using an RTCM in.
Right. Is it possible to get sub-foot accuracy with SBAS only?
Sub-foot with SBAS only, I would say probably not. Because we're only using an L1 receiver and we're getting a real-time solution with SBAS, sub-foot might be a little too far to reach. Now, in the data that I showed, I'm going to jump over there real quick. Sorry for the quick scrolling. You'll see that most of the data fell within a 1-foot radius circle. I can't guarantee that's going to happen in every location, under every environment. I do know that 95% of the time I'll be within a couple feet.
Okay. Have you tested the accuracy in dense West Coast conifer forests and would that be, and what would the accuracy be RMS 95%?
Okay, we did some preliminary testing up at the Missoula Technical Testing Center, Powell, up at Powell, Idaho. And in the preliminary testing, we got pretty good results. Obviously, you're in heavy tree canopy, so you can't expect sub-meter real-time performance in that environment. Some of our early testing demonstrated comparable performance with that type of receiver, or that particular model receiver when it's used in that environment. I don't want to publish numbers yet because we are still finishing some of the Geode Connect software design and finalizing some of the default settings on the receiver. We will be doing additional testing shortly.
Oh yeah, can you tell me which version of RTCM the system is compatible with?
Currently, it's compatible with RTCM 2. Okay.
And the last question I think we have time to cover here is, could you repeat the name of that Polish company that you saw?
Oh yeah, I believe the company name was Taxus. I think you can find their website, TAXUS. It was a really neat product.
Okay.
All right. Okay. We're going to do a quick scroll over again. Sorry for the flashing screen. Just to summarize, Geode is our newest solution to provide real-time sub-meter GNSS positioning to Juniper systems and UIOD bring your own devices running Windows Mobile, Windows PC, and Android operating systems to the field GIS and mapping world. The Geode is designed to be an open architecture product. It's intended to work with your apps on your devices. And it continues the Juniper systems concept of reliability and ruggedness, and products that are designed to work with it too. If you would like to contact us, get more information in the Americas and Asia and the Pacific, contact us here at Juniper Systems, Inc. If you're in Europe or the Middle East or Africa, you can contact our good friend Simon at our Juniper Systems office in Bromsgrove in the UK. And of course, we're always available online. And for all the attendees, we will send you a follow-up email with additional information and background on the products. I want to thank you all for taking the time out to participate, and those are some really good questions that people asked. That'll help us to build better materials for your resellers out there to help you communicate better about the product to your customers. Like I said, additional information will come out in an email, and I want to thank you all for attending and have a great day.